And then what I want to do is spend a few minutes at the end talking with people about how their project teaming is going and what they need in terms of help for getting a group together. We'll take a look at the shared document together. So like I was saying, in the interest of time, I don't have much as far as preamble goes today. Again, just a reminder, this session is being recorded and live streamed, just like every other session throughout the week. And you can find the hackathon materials through the following links. So just to post, we've seen this slide a bunch. This is just the links to all of the hackathon information. I'll post this in the chat one more time. So again, if you do have a project idea and you haven't added it to the shared document yet, please do so as soon as possible so that people can review these on their own time. Also, if you put your name in the project document as looking for a group, but you have since then found a group, please go ahead and move your, I've added a space under each project for group members. So go ahead and move yourself down to that page in the document just to show that you've already found a group. That'll let us know who's still looking for help at the end of the day today. Okay, so with that, I just want to jump straight into our lightning talks. So I will go ahead and stop sharing, or actually, I guess let me put that back up for just a second. So again, the focus here, I'll probably give you between 3 and 4 minutes each, so we have time for discussion afterwards. And if you could just focus on those 3 slides again, the biological background, your modeling goals, and the potential teammates that you're looking for. I'll give you each 4 minutes, and I'll let you know when you have a minute left. So I guess let's start with Nasheen, if it's okay. Is that how you pronounce that? Oh, is she here? Yes, okay. I think you might be muted, Nasheen, if you're trying to talk to us. I don't see Nasheen on the participant list. Is anybody else missing? Oh, wait, there she is. She's at the top for some reason, not in alphabetical order. Nasheen, we can't, I see you're unmuted, but we can't hear you.
Can you hear me now?
Yes.
That's good.
Oh, okay, awesome. Sorry, I don't know what happened. Let me share my screen again. Can you guys see my screen?
Yes.
Okay. So my name is Nasheen. I'm a PhD student at SUNY Binghamton. I work with NMT modeling, but for calcific aortic valve disease. I'm currently looking at other pathways like BMP and ROA, ROC pathways. But for CC3D antibody network modeling and implementation, I would focus on the TGF-beta pathway because that's like a very well-known pathway. I know all the parameters for that. And it was already modeled by a colleague of mine a couple of years ago. So I just like to tackle that problem and see where that leads me. So a little biological background on endothelial to mesenchymal transformation. It's just that the endothelial cells, they transform into mesenchymal cells. And like, this is just like an overview of how the cell, they change their phenotype, the physical appearance changes. There's a different number of there's a lot of factors that can be involved in this transformation. But what happens is that when they transform into mesenchymal cells, their tight cell junctions, they are lost, and then the cells become more motile, and they have increased secretions as well. there are certain factors that are reduced, certain markers that are present in endothelial cells. For example, the VE cadherin and PCAM1 that are reduced, and markers of mesenchymal cells, they are produced more in this after the transformation. So a lot of factors are involved. There can be biochemical cues, including some molecules like TGF-beta from the surrounding environment that can activate this transformation. And this transformation is a very important, plays an important role in various biological processes, naturally, like during the development of an embryo or even wound healing when an injury occurs. But sometimes it can turn pathological, like in cancer. In cancer cells, we also see this transformation of the endothelial cells to mesenchymal cells. So problem motivation that, so I'm gonna try to focus on the TGF-beta signaling pathway, which also is one of the molecules that can be responsible for the process of NMT. And so for modeling goals, oh, sorry, I should have put this before, that this is like a huge pathway. Obviously, I don't think I'll be able to do the whole thing. I did attend Dr. Soro's workshop 2 weeks ago for antimony modeling. So I do have the model, the antimony model with me for the TGF-beta pathway. It's still like a work in progress, but I'm hoping to finish by tomorrow. So I have something to start off with. So for the modeling goals, I'd like to develop a multi-scale model for this this endothelial to mesenchymal transformation by using the TGF-beta signaling pathway, and try to integrate the antimony model that I have in CC3D. So the first step, development of
We have about 1 minute left, Nashi.
Oh, sorry. Okay, I'll just try to go through this. So just a number of steps that I have in mind is development of the antimony model that is already like in progress, as I said, and then the implementation of that model in CC3D at the tissue level, cellular level, and I have some chemical fields that can be included in. And to keep it simple, I'll be using only a few cells. These are my resources. Personally, I am more biologically strong. Looking for teammates, even with biological background, doesn't matter, but preference is strong computational background. Open to more suggestions and ideas if anyone has any questions.
Great. I know when people presented in the preparatory hackathon meetings, there were quite a few people who were interested in motility during cancer progression and metastasis. And so there may very well be teams that are working on related topics. And I think it's a topic that's likely to be of interest to multiple people. And so whether you do it as your own team or you work as a group with other teams, I think that this issue of TGF-beta and epithelial mesenchymal transition is a critical one. And it's a good, I think, a very promising one for CompuCell type treatment.
Okay, thank you. If anyone is interested, I'll leave my email in the chat.
Great, thank you. All right, so Darshan, we could have you go next.
Yep, I'll just share the screen. Yeah, I hope you can see the screen.
Yeah.
So, hello everyone, I'm Darshan. I'm a PhD student at IIT Bombay. And my hackathon pitch is around modeling of epithelial cell migration. Just a second. Yeah. So, collective cell migration is important in many biological processes, from embryonic development, organ growth, organ maintenance, and cancer metastasis. So wound healing is one of them, where the cells divide and they move as a collective to close a gap. And so it is a complex process that involves physical as well as biochemical cues. So in the image over here, which I've taken out from this paper, you can see that we have focal adhesions, which are cell substrate interactions, gap junctions and adherence junctions, which are cell-cell contacts. And you have the physical force transduction via the actomyosin cortex. Moreover, you have the cell polarized because of the way these actomyosin filaments are organized, as well as how the biochemical signaling molecules like Rho, RAC, CDC are spatially polarized. And this is the whole picture of how this cell migration works in a single cell level. And one of the properties that is useful is maintaining a certain density. So epithelial cells at a certain maintain a certain density at homeostasis, and that density is important for wound closure. So in the movie on the right, you can see healthy cells, and in the left you can see unhealthy cells. We are characterizing them as unhealthy because they are at a different density level, and a lot of things are going on in this movie, but you can clearly see that the collective migration in the healthy epithelium is much faster and more persistent than in the unhealthy tissue. So this is the biology of the epithelial cell wound healing that we are trying to look into. The motivation is, so the hypothesis is that the monolayer with an impaired mechanosensing or a biochemical signaling would lead to the loss of persistent migration. So it can be either one, or it can be both of them. We don't know. We'll have to check. But for our simulations, we can start with changing the density first at homeostasis, and then we can see where it goes. The broader goals of such type of modeling is to develop a fundamental understanding of how this biochemical and the physical cues interplay, and how it leads to such complex process. So this is a very broad project, but for the hackathon, I'm thinking of scoping it to just model it at homeostasis and incorporate some basic signaling into the model. So yeah, as I was saying, the goal is to first match this cell shape and density fluctuations at homeostasis from the simulation to the microscopy videos that are available. Next, to check for persistent cell migration, we will predict wound closure velocity in a sort of barrier release wound healing assay, which is a
1 minute left, Darshan.
All right, which is a technique where cells are, it is a technique, experimental technique. And so the plan is to use the vertex models among all the different modeling strategies, as they have, they are basically the, they provide a balance between the complexity and the simplicity of the model. And in this context, we will need to combine a physical model with a biochemical one. So the inputs will be the time-lapse images and the biochemical interaction data. And then we'll see if we can predict the collective migration velocity through the model. Yeah, these are a few resources for getting started with it. And we can even look at replicating like some of these models to begin the hackathon. And about me, I'm a chemical engineer, a background in systems biology, a little bit of modeling biochemical networks, and I also have some familiarity with Python. It would be helpful if I can be paired up with someone who is proficient with CompuCell, because this is my first week exploring this tool. And someone who's experienced in developing physical models, but I'm open for doing this hackathon with anyone who's interested in understanding more about this process. So yeah, that was it from my side.
Great, thank you. I know at one point, I think it was Issy, that did a presentation with the idea related to wound healing.
Right.
But I think
Yep.
Issy has joined another group already, so I'm not sure.
I was just looking because we have a set of lecture slides that did a simple wound healing assay simulation with collective migration.
Mhm.
I don't know whether those slides are going to be given this year, but if not, they're definitely available.
Yeah, we don't have it in the plan, but we'd be happy to share those.
Right. And so those are something you could build off of.
Yeah, that would be helpful. Yeah.
And if you add elongated cells to that model, it actually works pretty well.
Okay.
It doesn't have a lot of complex signaling in it, so you could do a lot more with it. But I was trying to find the deck because, in fact, the cover slide shows the wound healing the wound healing simulation. So I don't know where it got to, but Hayden, you probably found it.
Yeah, I'll have to take a
Yeah,
look.
sure. So I can build up on that during the hackathon.
That would be great. That's a great problem. Those tripod experiments are very beautiful.
Yeah.
Friedel and Tripod both do these incredible experiments in collective migration. Spectacular.
Yep. Yeah.
All right, great. So thank
Okay,
you,
yeah.
Darshan. And Carly, if you would like to go ahead and get queued up. All right, just whenever you're ready, go ahead.
So my name's Carly. I just finished my first year as a genetics PhD student at North Carolina State University in the NASCO and Yoder lab. And I wanted to propose kind of a simple hackathon project for modeling the effects of a sticky ECM on tissue architecture. So the extracellular matrix is a three-dimensional structure composed of collagens, elastin, and various proteoglycans and glycoproteins. And we know it's responsible for the regulation of cell interactions and tissue dynamics, and it allows cells to attach and communicate with one another. So ECM components are constantly being deposited, degraded, modified. And the different combination and spatial organization of the secreted substances gives rise to different types of ECM scaffolds, which then are able to characterize the properties and function of each organ and tissue. Among other things, the existence of these orderly structures is made possible by cell adhesion facilitated by the ECM. So as far as modeling goals, I'd like to have the ability to investigate individual ECM properties quickly and determine how the differences in these properties might affect tissue architecture as a precursor to biological experiments. And I'd like to predict how cadherent activity in the extracellular matrix contributes to changes in tissue architecture. So for that purpose, I'd like to simulate the secretion of extracellular matrix in a specific area of a multilayered tissue to see if it might lead to cell aggregation in that area, or if tissue segregation can be induced by varying ECM secretion in different cells. So just some quick visuals. This is a figure from Steinberg's classical differentiation adhesion hypothesis paper. So I was thinking about potentially recreating this in CompuCell. Basically, they had two cell lines that expressed an identical cadherin at very different levels. And then these were observed to sort out from a common aggregate. Or I'd like to observe the effects of cell adhesion mediated by cadherin molecules and extracellular matrix proteins by having some of the cells within a multi-layer tissue secrete like these little smaller cells that would be sticky to represent a different extracellular matrix composition. And as far as broader impacts, I think this could have a really wide range of future applications. I realize that it's super simple. I'm like brand new to CompuCell. Restructuring of tissue architecture occurs at many different times during an organism's life, and cell migration on and through extracellular matrix is fundamental in a wide variety of phenomena. So it could have applications to wound healing, embryonic development, cancer research, all kinds of things. As far as potential teammates, as I mentioned, so my background is mostly in biology and biochemistry. I don't have any prior modeling experience and very little experience coding. So interested team members with expertise in those areas would be great, but any backgrounds would be welcome. And I was thinking that this might be attractive to people who maybe think that a project like this would be a good foundation for their more complex issue that they'd like to model. And I'm definitely willing to expand the project in any direction, time permitting, during the hackathon. And I'll drop my email in the chat if anybody's interested.
Great, thank you. Yeah, Carly and I have talked about this a little bit over email already, but I just wanted to reiterate that there's absolutely nothing wrong with starting with a simple idea for the hackathon. You can always add complexity as you go. If it turns out that your idea was actually pretty straightforward, it is much more difficult to start constraining a project, at the end of the first day once you realize that the idea is too big. So it's always good to start small with something that you think might be too easy to implement and then start adding complexity on top. Much easier to course correct if you start that way. So great. James, any thoughts before I move on?
I was just typing a comment in the chat, but
Okay.
but that's.
So I think so I don't want to delay lunch too much because we have our guest presentations today. And I want people to be able to get back in time for those for sure. So what we're going to do is we do want to re-administer the hackathon participation poll, just to kind of get a confirmation on who's still planning on participating in the hackathon. One thing I do want to note is if for question number 2, I'm going to go ahead and launch this here. Question number 2 is, do you have a hackathon project in mind? Since I think we're officially finished with lightning talks, if everybody could just answer no to that, that way we don't have confusion in our data about that one, but the rest of them answer as you see fit. While people are filling that out, what I wanted to do was check in with people who have already started organizing projects. I know we have one that is more or less full. It is Karina's project. So what I will do actually here is I'm going to put a link to the shared document in the chat. And if everybody, I will share my screen as well here. If everybody who's leading a group could just take a look at this with me for a minute. So we have currently 9 projects in the document. And sorry, just responding to a comment here. Okay, so Karina's telling me that there are 4 people in their group now, and if there's another person who's still interested in that project, they now have an opening available. So I just wanted to see, we've got 9 groups here, and I assume, Carly, if you want to add yours, and Nasheen, I think. I just wanted to get a feel for if all this information is still accurate. So if Max is still looking for members, if James is still looking for members, if Norma, you're still looking for members. Bharat says this doesn't seem like the right document. No, it's the 2022. Okay, hang on. I don't know why this link, I can't get the right link. For this is like, okay, here's the correct link. At some point, I accidentally pasted the link for last year's document into one of my slides, and that link has been propagating throughout all of these things, so I apologize for that. I need to play yakety sax over this next time. But okay, so yeah, I just wanted to double check with the groups that are on here if the status of this is correct, and if the people looking for projects to join are still not assigned. So if you have joined a project and your name is on this list, go ahead and move yourself to the group members space at the bottom of that project.
And if any projects have been withdrawn, please let us know. Of course, if you've withdrawn it and you're not here in the room, then we can't ask that. But if you proposed a project and you don't want to do it, we'd be sad, but we'd like to know. So we don't want people signing up for a project that doesn't exist.
Yeah, and if by kind of midday tomorrow, if you had suggested a project, and if you unfortunately haven't had any interest expressed in it, please feel free to let us know. If you don't want to work alone, we can help you find a group maybe with a project that has at least similar themes. Instead of you having to build a project by yourself, unless you're interested in that. But I will say that trying to build an entire model in 2 days on your own, especially if you're not a CC3D expert, can be fairly difficult. So just know that going in, if you do want to work by yourself, that it will be quite a task. But we're happy to help you scope your project. If you are really committed to the idea and do want to try to do it on your own, we can help you scope it down into something that is prototypable within the 2 days of the hackathon. So it looks like there's been a couple of changes here. And we will have the entire hackathon session tomorrow just for discussion of things like that and for time for teaming. Because I think everybody that wanted to present has had a chance now. Don't forget about the hackathon Slack channel as well. That's a good place to talk to people outside of the workshop time, to do a little bit more real-time teaming. And like I said, you are also free. You have the permissions in the Slack workspace to create private channels for your group's team. If you would like to create a public channel, you can do that as well. But if you prefer just to keep that between you and the group members in the Slack, that is also fine. If you wouldn't mind, though, sending me an invite to your private group, just so that we can take a look at kind of the discussion that's going on over the course of the weekend. Because unless you give people in the Slack workspace permission to join the group, we can't see it. I need to make sure to remind people about that tomorrow. Not trying to spy on anybody. It's just good to know so we can give people the most effective help we can over the weekend. Okay, so I think since it's 2 o'clock, I want to get people off to lunch. And we will have more time tomorrow to discuss actual projects and teaming. Pedro messaged me earlier to let me know that there was a second, oh goodness, I'm still sharing my browser, aren't I? There was a second typo in the email that I sent out earlier. TJ's session name was incorrect, so I'm going to put up, this is the dangers of sending late night emails.
Maybe put the links in the chat now.
Yeah,
and
I
then
will.
also post them on them.
I have a splash screen here. Sorry, having issues with the share. Okay. So while I put these in the chat, I will leave this. Now it is. Here are the links to today's sessions. So TJ's session is titled, hopefully you all got the new abstract. TJ's session is titled Advanced Applications Working with the CC3D Python API. So again, like I mentioned this morning, this is for more advanced users of CompuCell. If you're really interested in how CompuCell works with Python API, you're welcome to attend, of course, but this session will be better suited, I think, to people that had some knowledge coming into this and are interested in integrating CompuCell with other Python applications. So any questions about this before we go? I'll make this full screen now.
I'm just checking, are all 3 sessions going to be recorded?
They will be recorded. They won't be live streamed, so they will go up on YouTube
Oh, awesome. Thank you.
at the end of the day.